Hello students, I hope that you are good, well and fine. Today we will be starting a new chapter, 3-dimensional geometry, chapter 11, class 12. So let's right jump to our chapter. So let's see some introduction part. So in class 11, you have studied or you have analyzed some geometry part or what are two dimensions. And the introduction here, the 3-dimensional geometry, we are confined to the Cartesian methods only. Okay, in the previous chapter of this book, okay, you have studied what about vectors, if you remember. We'll now use that concept here also. Okay, the purpose of this approach to 3D geometry makes it simple. That's why we are going to use our vector concept. Okay, now in this chapter, what are the topics you are going to learn about? The cosines, direction ratios of a line joining 2 points. Okay, we also saw in vector algebra chapter. Okay, clear? Now, here we will be seeing about equations of line and planes in different conditions. Okay, angle between two lines, two planes, a plane and a line, shortest distance between two skew lines. You will know that what do we mean by skew lines, distance of a point from a plane. Okay, all we will be studying but in a different way. Okay, now let's see. So first is direction cosines and direction ratios of a line. So let's recall some of the things that if you have a directed line L passing through the origin, okay, makes angles alpha, beta, gamma with x, y and z axis respectively, called direction angles. Okay, then cosines of these angles we will be calling them as cos alpha, cos beta and cos gamma as direction cosines of the directed line L. If we reverse the direction of L, then the direction angles are replaced by the supplement, that is pi minus alpha, pi minus beta and pi minus gamma. This results that the direction of cosines are also going to be reversed. Okay, as you can see here, this is your 3D space. With x-axis, you are having alpha angle. With y-axis, you are having beta angle, and with with z-axis, you are having gamma angle. Okay. Now, note that a given line in a space can be extended in two opposite direction. Yes, and so it has two sets of direction cosines. Yes, in order to have a unique set of direction cosines for a given line in space, we must take the given line as a directed line. Okay, this unique direction cosines are denoted by LMN. Yes, remark, if the given line is space doesn't if a given line in space does not pass through the origin, then in order to find its direction cosine, we draw a line through the origin and parallel to the given line. Now take one of the directed lines from the origin and find its direction cosines as two parallel lines have same set of directions cosine. Okay. Now, so any three numbers which are proportional to the direction cosines of a line are called the direction ratios of the line. Okay. The L, M and R direction cosines and ABC are direction ratios of a line. This means A will be lambda times L, B will be lambda times M and C will be lambda times N, where N will be your scalar which is non-zero. Okay. Now, ABC are direction ratios of a line and LMN are direction cosines of the line. Then you will have this condition that L by A is equals to M by B is equals to N by C is equals to some constant. Okay. Therefore, L is equals to AK, M is equals to BK, N is equals to CK. But therefore, you also have this condition that L square plus M square plus N square is equals to 1. This means K square times A square plus B square plus C square is equals to 1. This means K will be plus minus 1 by root A square plus B square plus C square. Okay. Okay. Hence from 1, you can have the direction cosine of the line R. L is equals to plus minus A divided by magnitude. As you can see, M is equals to plus minus B divided by A square plus B square plus C square. N is equals to plus minus C divided by A square plus B square plus C square. Okay, I hope it is clear to you. Okay. Now, direction cosines of a line passing through 2 points. Now, how you are going to find that? Quite simple. If you have 2 points P and Q, then you know LM and N be the direction cosines of the line P. Let it makes angle alpha, beta and gamma with the x, y and z axis respectively. Okay, as you can see PQ line here. Yes, PQ line, the alpha angle, the gamma and beta. Okay, now draw perpendicular from P and Q to xy. Okay, xy plane to meet at R. Okay, to meet at R and S. Draw perpendicular from P to QS, P to QS to meet N. As you can see here, so perpendicular from P onto the xy plane, this is your R point. Same with Q, your S will be the point, and same with PN will be the perpendicular on QS, as you can see. Okay, clear. Now what? Now in triangle P and Q, if you try to see P and Q, this triangle, P and Q triangle, the angle PQN, the angle PQN will be your gamma. This means cos gamma will be what? Base, yes, base which is NQ by hypotenuse which is PQ. So base NQ divided by PQ is equals to Z2 minus Z1 divided by PQ. Okay. So in this same manner, you will have what? In the same manner, you will have what? Okay. You will have cos alpha x2 minus x1 divided by PQ and cos beta is equals to y2 minus y1 divided by PQ. Okay. I hope it is clear. Okay. Now, the direction cosines of the line segment joining the points P and Q are these, where PQ will be the root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Note that the direction ratios of the line segment joining P and Q may be taken as x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2 and z1 minus z2. Okay. Now, example 1. If a line makes angles 90, 60 and 30 with the positive directions of x, y and z axis respectively, find its direction cosines. So quite easy. L will be cos 90, M will be cos 60, N will be cos 30. Means 0, half, root 3 by 2 respectively. Now, if you are having direction ratios as 2, minus 1, minus 2, then determine direction cosine. Quite simple. 2 divided by root of sum of the squares of these, like root 2 square plus minus 1 whole square plus minus 2 whole square. Okay. Now, M will be minus 1 by root of 2 square plus minus 1 whole square plus minus 2 whole square. N will be minus 2 divided by 2 square plus minus 1 whole square plus minus 2 whole square. This means 2 by 3 minus 1 by 3 and minus 2 by 3. Okay. Now find the direction cosines of the line passing through the points minus 2 comma 4 minus 2 comma 4 comma minus 5 and 1 comma 2 comma 3. Okay, you have 2 points. Very easy to find. You just saw the formula. P and Q, if you have P and Q points, line passing through these 2 points, then you will have what? X2 minus X1 divided by PQ, Y2 minus Y1 divided by PQ, Z2 minus Z1 divided by PQ. PQ represent the distance, okay, which is root X2 minus X1 whole square plus Y2 minus Y1 whole square plus Z2 minus Z1 whole square. Here P is this, Q is this. This means PQ, the length from P to Q will be root 77. And the direction cosines will be 3 by root 77 minus 2 by root 77 and 8 by root 77. Okay, I hope it is clear to you. Very simple things are happening. Now, next example. Find the direction cosines of x, y, z axis. Okay. The x-axis makes angle 0, 90 and 90. Okay, respectively with x, y and z axis. Okay. This means therefore the direction cosines of x-axis are cos 0, cos 90 and cos 90. This means 1, 0, 0. Similarly, the direction cosines of y-axis will be y-axis and z-axis will be 0, 1, 0 and 0, 0, 1. The same logic will apply. Now the next example, show that the point A, B and C are collinear. As you can see, the direction ratios of line joining AB are 1 minus 2, minus 2 minus 3, 3 plus 4, that is minus 1, minus 5, minus 7. The direction ratios of the line joining BC are what? 2, 10, minus 14. It is clear that direction ratios of AB and BC are proportional. Hence, AB is parallel to BC. Yes? But point P is common to both AB and BC. Therefore, ABC are collinear points. Okay? I hope it is clear to you. Okay. So, very easy. In order to find the collinearity or to show the collinearity, what you have to show? Somehow you have to show that you are having parallel things and common things. So this means the common things and parallel things only apply one case, that they must be lying on same line. Means collinear. Okay. Now we have arrived to exercise 11.1. So let's see. So problem 1 of this exercise says, if a line makes angles 90 degree, 135 degree, 45 degree with x, y and z axis respectively, find its direction cosines. Okay, very simple to find. Cos 90 you have to find, cos 130 you have to find, cos 45 you have to find. So cos 90 will be what? 0. Cos 135, how can you find your cos value 135? So it is from the trigonometry chapter. You can easily, or you can be able to easily find out this value. How? 90 plus 45. 90 plus 45 is 135. You know the value for cos 90. You know the value for cos 45. Apply the cos A plus B formula. You will have your answer as minus 1 by root. Okay. N will be cos 45. This means 1 by root 2. This means direction cosines will be 0, minus 1 by root 2 and 1 by root 2. Okay. I hope it is clear. Now, second problem. Find the direction cosines of a line which makes equal angles with the coordinate axis. Okay. So, this means that L will be your cos A, M will be your cos A and N will be your also cos A. Yes. Why? Because a direction cosines of the line makes an angle A with each of the coordinate axis. Okay. This means L square plus M square plus N square is equals to 1. We already know this thing, that L square plus M square plus N square is going to be 1. Okay. Now what? Now cos square alpha plus cos square alpha plus cos square alpha. This is A or alpha, we are assuming both equal to each other. Okay. Now means 3 cos square alpha is equals to 1. Yes, this means cos square alpha is equals to 1 by 3. If you apply root to both sides, you will have what? That cos alpha will be plus minus of 1 by root 3. Cos alpha will be plus minus of root 1 by 3. Okay. Thus your direction cosines of the line which is equally inclined to the coordinate axis will be plus minus 1 by root 3, plus minus 1 by root 3, plus minus 1 by root 3. All are the same. Okay. I hope it is clear. Now third, if a line has the direction ratios minus 18, 12, minus 4, then what are its direction cosines? Very easy. You have your formula. If a line has direction ratios of minus 18, 12 and minus 4, then its direction cosines are minus 18 divided by root of sum of the squares of the direction ratios, which means minus 18 divided by minus 18 whole square plus 12 whole square plus minus 4 whole square. M will be 12 divided by the same thing, which is root minus 18 square plus 12 square plus minus 4 square. Clear? Now n will be minus 4 divided by root minus 18 square plus 12 square plus minus 4 whole square. If you solve, you will have minus 18 by 22, 12 by 22, minus 4 by 22. You can simplify your things. You will have minus 9 by 11, 6 by 11 and minus 2 by 11. So the direction cosines will be minus 9 by 11, 6 by 11 and minus 2 by 11. Clear? Okay. Let us move to the next problem. Fourth one. Show that these 3 points are collinear to each other. The same logic we are going to apply. Okay. That the given points A, B, C are these 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 respectively. It is known that the direction ratios of the line joining the points x1, y1, z1 and x2, y2, z2 are given by x2 minus x1, y2 minus y1 and z2 minus z1. Yes, the direction ratios of A, B are minus 1, minus 2, comma, minus 2, minus 3 and 1, minus 4. That is minus 3, minus 5 and minus 3. The direction ratios of BC will be 5 minus minus 1, 8 minus minus 2, 7 minus 1. This means 6, 10 and 6. Okay. Clear? And you can directly observe that what is happening, that BC direction ratios are just nothing but 2 times of AB direction ratios. This means proportional. They are proportional to each other. This means they are parallel to each other. Okay, AB and BC are parallel, but they are having same point B. B point is common to both. This means they must be lying on the same line. Okay, so this means they are collinear. They must be collinear. So ABC point must be collinear. Now the last problem, fifth problem. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2 and minus 5, minus 5, minus 2. Okay. So vertices of triangle ABC are given these. So let's see a visual figure for it. So A will be this vertex 3, 5, minus 4. B will be minus 1, 1, 2. C will be minus 5, minus 5, minus 2. The direction ratios of side AB are, as you can see for this AB are minus 1, minus 3, 1, minus 5 and 2 minus minus 4. This means minus 4, minus 4 and 6. Okay. Now what? now we have to find this, that root of -4 whole square plus -4 whole square plus 6 square, you will have root 68. This means 2 multiply root 70. Then you can easily be able to find out your direction cosines of AB. In order to find your direction cosine, you must know these direction ratios and this value. Okay, so you will have, for AB, you will have -4 divided by this 2 root 17 thing, then -4 again divided by 2 root 17, then n will be, this means cos gamma will be, or means this will be 6 by 2 root 17. If you simplify, you will get -2 by root 17, -2 by root 17, and 3 by root 17. Okay. Now for BC, the direction ratios will be -5, -1, -5, -1, and -2, -2. That is -4, -6, and -4. Okay. So the direction cosines of BC will be -4 divided by root of -4 square plus -6 square plus -4 square. Now for M will be -6 divided by the same thing, root -4 square plus -6 whole square plus -4 whole square. And N cos gamma will be -4 divided by -4 whole square plus -6 whole square plus -4. The denominator will be 2 root 17. Numerator will be -4. For M, it will be -6 by 2 root 17. For N, it will be -4 by 2 root 17. Simplify, you will get your simplified version. Now, for direction ratios of CA, you have -5, -3, -5, -5, -2, -4. You will have -8, -10, and 2. Therefore, the direction cosines of AC are -8 divided by -8 whole square plus 10 square plus 2 square. -5 divided by -8 whole square plus 10 square plus 2 square. N will be 2 divided by -8 square plus 10 square plus 2 square. This means -8 divided by 2 root 42 minus 10 divided by 2 root 42, 2 divided by 2 root 42. Okay. So with this, the last problem of this exercise 11.1 is done. Okay, so this is it for today's session. I hope that you understood the concepts, examples, as well as this 11.1 exercise. Yes. Okay. So please do not forget to memorize or to revise it. The main formulas for direction cosine. What do we mean by direction cosine? What do we mean by direction ratios? How to evaluate direction ratios, direction cosines? If conditions are given, according to the condition, the corresponding steps, what are the corresponding steps which lead us to the answer? Okay, so this is it for now. We will be back with more concept from this chapter, three-dimensional geometry. So again, thank you.